Exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Problem number 1. X square minus 2x minus 8. Our aim is to find the number of zeros of this quadratic polynomial. There is a method to find the number of zeros of the quadratic polynomial. I will consider this one as x square minus 2x minus 8 is equal to 0. Then when you solve this quadratic equation, you will get values of x. That is nothing but the number of zeros of this polynomial. How to solve this quadratic equation? There are several methods to solve this kind of quadratic equation. I will go through factorization method. Factorization method means we need to multiply first term and last term. This is the middle term, this is first term, this one is last term. Multiply these two, what will you get? Minus 8 into x square is minus 8x square. Next step is we need to write the factors. Factors of 8 are 4 and 2. Next, when you multiply these two terms, 4 and 2, you need to get 8, minus 8. And when you add these two, you need to get middle term, this one. We need to be very careful while choosing the terms here. How to split this one then? 4 and 2. If I take plus 4 and plus 2, I will get 6. When I add these two, I need to get minus 2. Then how to choose? If I take plus 4 and minus 2, I will get plus 2. This is also wrong. That's why I will choose minus 4 and plus 2. Then I will get minus 2. If I add minus 4x and plus 2x, I will get minus 2x. If I multiply these two, minus 4 into 2, that is minus 8. Product should be minus 8, and when you add those two, you need to get minus 2. You need to be very careful while choosing the terms, these two, minus 4x and plus 2x. Right, substitute here minus 2x as, write minus 2x as middle term, splitting this one, minus 4x and plus 2x. Minus 8 is equal to 0. This step is very, very important. And take the common term x. X minus 4 plus 2 x minus 4, 0. X minus 4 common, x plus 2 is equal to 0. Then you will get, x minus 4 is equal to 0. X plus 2 is equal to 0. X is equal to 4. This is minus 4. And x is equal to minus 2. You will get two values for x. I will take this one as alpha. Alpha is 4. This one as beta. Beta is minus 2. Okay. These two are the zeros of the polynomial x square minus 2x minus 8. That is the zeros of polynomial. First question is, the answer for first question is this one. 4 and minus 2 are the zeros of the polynomial x square minus 2x minus 8. Second question is, we need to verify the relationship between coefficients and the zeros. Okay, if the equation is like this: ax square plus bx plus c is equal to 0, then alpha and betas are the roots, zeros of this polynomial. Then the relationship between alpha and beta is alpha plus beta is minus b by a, and alpha into beta product is alpha beta is c by a. That is the relationship between alpha and beta and coefficients b and a. B is coefficient of x, A is coefficient of x square. Just comparing this one with this. Just write this one. Okay, write the coefficients of x square first. A is, what is A? A coefficient is here. X square coefficient is A, here 1. And B, here minus 2. And C is minus 8. Just compare with this standard form: ax square plus bx plus c is equal to 0. Then write alpha plus beta. Sum of the zeros is minus b by a. Alpha is 4, beta is minus 2, minus of minus plus. 4 minus 2, 2, minus minus plus. 2 is equal to 2. Then alpha into beta, c by a. Alpha is 4, beta is minus 2, c is minus 8, b is 1. Minus 8 is equal to minus 8. That's why the relationship between zeros and coefficients is verified. Thank you so much. Let's move to next problem. Next problem is second one. 4s square minus 4s plus 1. This is the polynomial. I will write 4s square minus 4s plus 1 is equal to 0. This is the equation. When you solve this equation, you will get values of s, that is nothing but zeros of this polynomial. Whatever the polynomial they have given, first consider the given polynomial is equal to 0. Then solve this one. How to solve this one? Middle term is minus 4s. First term is 4s square. Third term is 1. When you multiply first term and third term, you will get 4s square. Okay, we need to find the factors. Factors of 4s square, and factors of 4s are 2 and 2. 2 2s are 4. Okay, 2 and 2. Here, if I take plus 2 and plus 2, if I add these two, I will get plus 4. But always look at the middle term. When you add these two terms, you need to get the middle term. When you take the product, you need to get this one, 4. 4s square we need to get. If I take plus 2 and plus 2, I will get 4. This one is not possible. Always do in roughly this one. If I take minus 2 and minus 2, I will get minus 4. If I multiply minus 2 and minus 2, I will get plus 4. When you take the product, it must be plus 4. When you add those two, it must be minus 4. Okay, that's why I am taking minus 2s and minus 2s. Minus 2 into minus 2 is plus 4. Minus 2 plus minus 2 is minus sign. You need to add these two. Minus 4. 4s square minus 2s. This one splitting minus 4s as minus 2s and minus 2s. Plus 1 as it is equal to 0. And here 4s square minus 2s, from these two, that implies 2s is common. 2s into 2s, 4s square minus 1. 2s is common. Minus 1 I will take common from these two. Minus 1 is common. Minus 1 into 2s is minus 2s. Minus 1 into minus 1 is plus 1 is equal to 0. 2s minus 1. 2s minus 1 is equal to 0. 2s minus 1 is 0. 2s minus 1 is equal to 0. 2s is 1. 2s is 1. S is 1 by 2. S is 1 by 2. In this case, alpha value, one of the 0 is 1 by 2, another 0 is 1 by 2. Zeros of the polynomials are 1 by 2 and 1 by 2. Next, I need to find the relationship between zeros and the coefficient. Suppose the equation is like this: as square plus bs plus c is equal to 0. Okay. Then alpha plus beta is b minus b by a, and alpha into beta is c by a. This is the relationship between alpha, beta, zeros and the coefficient b by a. This sum is always minus b by a and product is c by a. When you compare this one with this one, the given problem 4s square, you can easily write the values of a. A is, when you compare this one with this, a is 4, and in place of b minus 4 is there, and c is 1. Okay, write those. Then consider the sum alpha plus beta minus b by a. Alpha is 1 by 2, beta is 1 by 2, minus of minus 4 by a is 4. 1 by 2 plus 1 by 2. You need to take the LCM 2. 1 plus 1. And here minus minus plus 4 by 4. 4 by 4. 1 plus 1 is 2. 2 by 2 is equal to 4 by 4. 2 by 2 is 1, 4 by 4 is 1. This one. Sum of the zeros is equal to coefficient minus b by a. This relationship between sum of zeros and coefficient of zeros, this one is verified. And next, I need to take the product of zeros and coefficient is alpha into beta is c by a. Alpha is 1 by 2, beta is 1 by 2, 1 by 2 into 1 by 2 is equal to c is 1, b is 4. 1 by 2 into 1 by 2, when you multiply this denominator, 1 by 4 is equal to 1 by 4. This one also verified. In the third problem is, third one, 6x square minus 3 minus 7x. Okay, this is the polynomial they have given. Our aim is to find the zeros of this polynomial. I will write this one as 6x square minus 7x minus 3. This one is equal to 0. I rearranged this one. This is minus 7x. I wrote middle because here x power 1 is there, and last constant term I will write third term as constant term. When you solve this one, then you will get values of x. That is nothing but the zeros of this polynomial. That is the answer for our question. First question. Next, we need to find coefficient and relationship between coefficient and the zeros. Later we can do that. First, solve this one. There are several methods to solve this kind of quadratic equation. I will go through factorization method. This is the first term, this is the middle term, this is the third term. In factorization method, we are multiplying first term and the third term. First term is 6x square, third term is minus 3. When you multiply 6x square and minus 3, you will get 6 3s are 18, minus sign as it is, minus 18x square. Minus 18x square. We need to split this one middle term. For that, in this method, we need to first find the factors of 18. Factors of 18 are 9 and 2. Okay, 9 and 2. If I multiply these two, I need to get minus 18. Then I need to, if I take minus sign for 2, I will get 9 minus 2. If I add these two, 9 plus minus 2, I will get 7 plus 7. If I add these two terms, 9 and 2, if I add these two, I need to get minus 7. If I multiply these two, if I take the product, I need to get minus 18. Then we need to be very careful while choosing the sign for this. If I take plus 9 and minus 2, I will get minus 7. This is not possible. If I take minus 9 and plus 2, I will get minus 7. This one is okay, minus 7. And if I take minus sign 9 and plus 2, I will get minus 18. Okay, then I will choose minus 9x and plus 2x. I won't take my plus 9x and minus 2 because our middle term is minus 7x. Okay, when I split this one minus 7x as minus 9x and plus 2x, I'll get minus 7x and minus 3 as it is equal to 0. And here 6x square is there, here minus 9x is there. From these two, 3x is common. I'll take 3x outside. 3 2s are 3 6 minus 3 3s are 9. And from these two, I will take 2x minus 3 is there, plus 1 outside. Why I am taking plus here? Because the common term is 2x minus 3, we already got here. That's why to get the common term 2x minus 3, I am taking plus sign outside. Plus 1 is equal to 0. 2x minus 3, 3x plus 1 is equal to 0. 2x minus 3 is equal to 0. 3x plus 1 is equal to 0. 2x is equal to 3. 3x is equal to minus 1. You can write x is equal to, this 2 will go to denominator, 3 by 2. X is minus 1 by 3. X value minus 1 by 3. This is nothing but alpha, one of the zeros, 3 by 2, another beta, minus 1 by 3. These two are the zeros of this polynomial. Next, we need to find the relationship between zeros and coefficients. I will write the standard form ax square plus bx plus c is equal to 0. Then sum is alpha plus beta is minus b by a, and product of these two is alpha beta. Sum of these two is minus b by a, and product of these two is c by a. When I compare this one with the standard form, this equation with the standard form, I can write values of a as a, x square coefficient 6, a is 6, and x coefficient is minus 7b, and constant term c is minus 3. Alpha plus beta minus b by a, alpha is 3 by 2 plus beta is minus 1 by 3 minus b is minus 7 by a is 6. when I take the LCM, 2 and 3, 6 is the LCM, 2 3s are 6, you need to multiply 3 to 3, 3 3s are 9 plus 3 2s are 6, 1 2s are minus 2 is equal to minus minus plus 7 by 6. 9 minus 2 is 7 by 6 is equal to 7 by 6. This one is verified. Next I need to do alpha into beta is equal to C by A. Alpha is 3 by 2, beta is minus 1 by 2. Sorry, I will do here, next page. Alpha beta, alpha into beta is C by A. Alpha is 3 by 2. Beta is minus 1 by 3 is equal to C is minus 3 by A is 6. Minus 3 by 6. 3 into minus 1 minus 3. 3 into 2 6. 3 minus 3 by 2 is 6 is equal to minus 3 by 6. Minus 1 by 2 is minus 3 2s are 6. Minus 1 by 2. That's why the relationship between coefficients and this zeros of the polynomials are verified. Thank you so much. Let us move to the next problem. Next problem is fourth one. 4u square plus 8u. This is the polynomial. We need to find the zeros of this polynomial. Okay. First we need to solve this one. We need to take that this given thing as is equal to 0. This polynomial is equal to 0. Then when you solve this, you will get values of u. That is nothing but the zeros of this polynomial. If I take 4u square plus 8u is equal to 0, let 4u is common, u plus 2. From these two, you can write 4 into 2, 8, 8u will come is equal to 0. 4u is 0, or you can write u plus 2 is equal to 0. U is 0 by 4, u is minus 2. 0 by 4 is 0 only, and u is minus 2. These two are the zeros of the polynomial 4u square plus 8u. Here I will take alpha as 0 and beta as minus 2. Next we need to check the relationship between alpha, beta and coefficients ABC. Okay. That suppose the equation is like this: A u square plus bu plus c is equal to 0. Then alpha plus beta, product of these zeros is equal to minus, sum of these zeros is minus b by a, and product is alpha beta is c by a. Alpha, this is called alpha, this is called beta. And when I compare this one with this one, you can write that a is u square coefficient is a is 4, and b coefficient is, u coefficient is b, here u coefficient is a. There is no c here, constant term, you can write 0. Alpha plus beta is equal to minus b by a, sum of the zeros, alpha is 0, beta is minus 2, minus b is 8, a is 4, 8 by 4, minus 2 is equal to 2 2s are 4, minus 2, minus 2 is equal to minus 2. Next, alpha into beta, product is c by a, alpha is 0, 0 into minus 2, and c is 0, 0 by 4. 0 into minus 2 is 0, 0 by 4 is 0. 0 is equal to 0. Therefore, the relationship between the sum of zeros and coefficients are verified. Question number 5. T square minus 15. This one, here we need to find the zeros of this polynomial as well as relationship between coefficients as well as zeros. Okay. The problem is here t square minus 15. First write the given polynomial. We need to find the number of zeros of this polynomial first. There is a method to find the zeros of this polynomial. First write the given polynomial is equal to 0. Then when you solve this one, you will get values for t. That values of t is nothing but the number of zeros of this polynomial. That is the answer for first question. Okay, let me explain. How to find this one? This is the quadratic equation. You can write this one as t square is equal to minus 15 is in the left hand side. It will go to right hand side. It will become plus 15. Then you can write t is equal to plus or minus root 15. One value is root 15, another value is minus root 15. You got two values for t. This is nothing but alpha. I will take alpha is one of the zeros of this polynomial. T is root 15, another is minus root 15. This one is alpha. Alpha is equal to root 15 and beta is equal to minus root 15. These two are the zeros of this polynomial. Next, I will verify the relationship between alpha, beta and ABC. A, B, C are the coefficients of the A and B are coefficients of t square and t, and C is the constant term. This is the polynomial. Suppose at square plus bt plus c is the polynomial, then I will write this one is 0. Then alpha and betas are the zeros of this polynomial, at square plus bt plus c. Then the relationship between alpha and beta is alpha plus beta is minus b by a, and the product is alpha into beta is c by a. Let me explain first one. Alpha plus beta is equal to minus b by a. When you compare this one with this equation, at square plus bt plus c is equal to 0, you can write the coefficient of t square as here a is equal to here 1 and b is equal to, there is no t term here, you can write b is 0, c is minus 15, and then verify this relation. Alpha is root 15, beta is minus root 15, and c is b is 0, a is 1. Root 15 plus root 15 minus root 15 is 0. Minus 0 by 1 is 0. This relationship is verified. Let us verify this one. Alpha beta is equal to c by a. Alpha is root 15. Beta is minus root 15. C is minus 15. A is 1. Square root of root 15 into minus I will take outside. And suppose if it is square root of a into square root of a is there, you can write square root of a square. Square root and square will get cancelled, so you can directly write a. This one is in place of a 15 is there, you can write square root of 15 square is equal to minus 15. Square and square root will get cancelled. You can write minus 15 is equal to minus 15. The relationship between the zeros and coefficients of the polynomial is verified. Thank you so much. Last problem, sixth one. 3x square minus x minus 4. This is the given polynomial. We need to find the number of zeros of this polynomial. I will take this one as equation. 3x square minus x minus 4 is equal to 0. Then when you solve this one, you will get values of x. That is nothing but the number of zeros of this polynomial. I will go through factorization method. First term, middle term, third term. First I will take the product of first term and last term. This one, first term is 3x square, last term is minus 4. Minus 4 into 3 is minus 12 x square, and the middle term is here minus x. The factors of 12, 12 4 and 3. Factors of 12 are 4 and 3. If I take plus 4x and minus 3x, I will get plus x. When I add these two, I need to get minus x. That's why I will take minus 4x and plus 3x. I will get minus x. If I multiply minus 4 and plus 3, I will get minus 12. Okay, I will take minus 4x and plus 3x are the terms here. Minus 4x plus 3x is minus x. Minus 4x into 3x is minus 12x square. That's why I am taking minus 4x and plus 3x. 3x square as it is, minus x as minus 4x plus 3x. Minus 4 is as it is equal to 0. From these two, I will take x common, 3x minus 4. From these two, I will take 1 common, 3x minus 4 is equal to 0. 3x minus 4 into x plus 1 is equal to 0. 3x minus 4 is equal to 0. X plus 1 is equal to 0. 3x is equal to 4. X is equal to minus 1. X is equal to 4 by 3. X is equal to minus 1. I'll take alpha as this one. Alpha is equal to 4 by 3 and beta is equal to minus 1. These two are the zeros of the polynomial 3x square minus x minus 4. Next we need to find the relationship between alpha, beta and coefficients ABC. If it is ax square plus bx plus c is 0, then what is the relationship between alpha plus beta? Alpha plus beta is minus b by a and alpha beta is c by a. Then I will compare this one. 3x square minus x minus 4 is 0. You can write a as 3 and b is equal to minus 1. When you compare this one, c is minus 4. C minus 4 coefficient. Then alpha plus beta is minus b by a. Alpha is 4 by 3. Beta is minus 1 minus b is minus 1. A is 3. 4 LCM is 3. 1 is there. 4 minus 3 into 1 3. 4 into 1 4 and 1 into 3 3. That's why I will multiply this one by 3. 4 minus 3 is equal to minus 1 minus 1 plus 1 by 3. 4 minus 3 1. 1 by 3 is equal to 1 by 3. Then I will consider the product. Alpha beta is c by a. Alpha is 4 by 3. Beta is minus 1. C is minus 4. A is 3. Minus 1 into 4 minus 4 by 3 is equal to minus 4 by 3. Thank you so much. Relationship between coefficient and sum of zeros and zeros are verified. This one equal.
Second problem, find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. First one 1 by 4 and minus 1. They have given sum of the zeros as 1 by 4 and product of zeros as minus 1. Our aim is to find the quadratic polynomial.
Question number 2. the question number 2, in that first question, 1 by 4 minus 1. They have given product of the zeros as minus 1, sum of the zeros as 1 by 4. If alpha and beta are the zeros of the polynomial, then alpha plus beta sum is, they have given 1 by 4 and product is alpha into beta is minus 1. They are given these two. Our aim is to find the polynomial. We don't know what is the polynomial. Actually, if alpha and beta are the zeros of the equation, then zeros of the polynomial, then we can find the polynomial x square minus alpha plus beta into x plus alpha beta is the required polynomial. When you substitute alpha beta here and alpha into beta here, then you will get the required polynomial. I will write this one as equation and I will tell you how to get this equation. In exam you can directly write like this, but I will explain how to get that equation. Actually, standard form is like this: ax square plus bx plus c is the polynomial. I will write the equation. Okay, if alpha and beta are the zeros of the polynomial ax square plus bx plus c, then you can write alpha plus beta is equal to minus b by a, alpha beta is c by a. This is the sum and product of the polynomial ax square plus bx plus c. Okay, let me clear how to get this one. Okay, first I will divide this one by ax square by ax square plus bx plus c whole divide by this one by a, 0 by a also, right hand side. A will get cancelled, you will get x square plus b by a into x plus c by a is equal to 0 by a is 0. You get like this. Then I will substitute b by a as minus alpha plus beta. This one. Minus in bracket alpha plus beta b by a. This minus will go here into x. And c by a as alpha beta. This one is equal to 0. This is the quadratic equation. Substitute alpha plus beta as 1 by 4 into x, alpha beta minus 1 is equal to 0. That implies I will write 4 as LCM, x square by 1, 1 by 1. There is no 4 here, that's why I need to multiply 4 to x square. You will get 4x square minus, in the denominator 4 is there, no need to multiply 4 to x, just write minus x1 into x minus, here there is no 4, you need to multiply 4 to 1, you will get 4 minus 4 is equal to 0. That implies 4x square minus x minus 4, this 4 will go to right hand side, 0 into 4, that is 0. 4x square minus x minus 4 is equal to 0. This is the quadratic equation. But we need to find the quadratic polynomial. Therefore, required polynomial is, what is the polynomial? Polynomial means just this expression is called polynomial. We are not equating to 0. Required polynomial is the required polynomial, just write 4x square minus x minus 4. Don't write equal to 0. If you write equal to 0, that will become equation. Polynomial means just this expression. Next problem is problem second. They are given sum of the root 2 and 1 by 3. Sum of zeros as root 2 and product of zeros, alpha and betas are the zeros here. Alpha plus beta is root 2 sum, and product alpha into beta, that is 1 by 3. What is the equation? X square minus, in terms of alpha and beta, equation is like this. X square minus alpha plus beta into x plus alpha beta is equal to 0 is the equation in terms of alpha and beta. And substitute, try to remember this equation. X square minus alpha plus beta is root 2 into x plus 1 by 3, alpha into beta is 1 by 3 is equal to 0. I will take the LCM 3. Here there is no 3 here. I need to multiply 3 to x square. 3 into x square is 3x square minus, here also there is no 3. 3 into root 2x plus 1. Denominator 3 is there. That's why plus 1 as it is equal to 0. That implies 3x square minus 3 into root 2x plus 1. This 3 will go to right hand side. It will become 0. This is the required equation. Polynomial is, therefore, polynomial is 3x square minus 3 root 2x plus 1. This is the required polynomial. Let's go to next problem. Third one, 0 root 5. They are given sum of the zeros. Alpha plus beta is 0 and product of the zeros. Alpha into beta is root 5. And the equation is in terms of alpha and beta, x square minus alpha plus beta into x plus alpha beta is equal to 0. Substitute alpha plus beta as 0 here. 0 into x. Alpha into beta is root 5 is equal to 0. X square. 0 into x is 0 plus root 5. 0 plus root 5 is equal to 0. X square plus root 5 is equal to 0. Therefore, the required polynomial is x square plus root 5. This is the required polynomial, x square plus root 5. Don't write is equal to 0. Fourth one is 1, 1. Sum of zeros is 1. Product of zeros are 1. Equation in terms of alpha and beta is x square minus alpha plus beta into x plus alpha beta is equal to 0. X square minus 1 into x plus 1, alpha beta is 1 is equal to 0. X square minus x plus 1 is equal to 0. Therefore, the required polynomial is x square minus x plus 1. This is the required polynomial. Fifth one is 1 by 4, 1 by 4. They are given alpha plus beta. Sum is 1 by 4 and minus 1 by 4. Minus 1 by 4 and 1 by 4. Sum is minus 1 by 4 and product of zeros is 1 by 4. Alpha and beta are the zeros of the required polynomial. The equation in terms of alpha beta is like this: x square minus alpha plus beta into x plus alpha beta is equal to 0. X square minus alpha plus beta is minus 1 by 4 into x plus alpha beta is 1 by 4 is equal to 0. Minus minus become plus x square plus 1 by 4 into x plus 1 by 4 is equal to 0. After simplifying, we get x square plus x by 4 plus 1 by 4 is equal to 0 is there. LCM is 4. There is no 4 here in the denominator. That's why I will multiply 4 to x square. That is 4x square plus 4 into 1, x into 1, x. 4 into 1, 1 into 1 is equal to 0. 4x square plus x plus 1 is equal to 0 into 4. This 4 will go to right hand side. It will become 0. Therefore, 4x square plus x plus 1 is equal to 0. For the required polynomial is 4x square plus x plus 1. Required polynomial is 4x square plus x plus 1. This one. Don't write is equal to 0. Last one is x is 8th one. 4, 1 they are given. Sum of the zeros is alpha plus beta is 4. Product of the zeros is alpha into beta is 1. Equation in terms of alpha and beta is x square minus alpha into beta into x plus alpha beta is equal to 0. Substitute alpha plus beta, that is plus 4 into x. Alpha beta product is 1 is equal to 0. X square minus 4x plus 1 is the required polynomial. X square minus 4x plus 1.